So example 14. And we want to, and the question is going to be to simplify this. So we're going to simplify this. Now it's really hard. So when we can't actually cancel out these x's because this x is not multiplied by everything on its line. So these x's are not available for canceling, but we could make them available for canceling. What we could do is we could common factor out an x from the top. And that would give us 10x squared minus 5 over x. And what we actually could do, and I'm going to do it just because, we technically could have factored out a 5 as well, which would leave us with 2x squared minus 1 all over x. Now if we look at this, something cancels. What cancels? These x's cancel, and we end up with 5 times 2x squared minus 1. And that's it. So this expression over here is equivalent to this expression over here. But that's only true as long as, and we have to look for any restrictions. There's no denominator here, so there's no restrictions at all. But there is, and there is as well. And the restrictions are going to be that the bottom can't be equal to 0, and that's it. So this would be the answer. So if I'm trying to simplify this expression, it simplifies 10x cubed minus 5x over x, simplifies into 5 times 2x squared minus 1, where x is not equal to 0. So we want to simplify this thing. I think you know enough to pause this video and try this one yourself. I'm going to plow ahead. On the top, we could factor out an x, and we could also factor out a 3. So I'm going to do it in one step. We could factor out 3x, and we would get 4x to the 5 minus 5x to the 3 plus 2 all over 3x. And that's kind of pretty. So those guys will cancel. That leaves a 1 on the bottom, which we're not going to write. So that's going to give us 4x to the 5 minus 5x cubed plus 2. And the restriction, of course, is that as long as x is not equal to 0. So what does this one simplify into? This one simplifies into, I gave a pause there for people who want to think about it. These cancel, and it just simplifies to 2. It simplifies to 2. So this expression and this expression are equivalent expressions. However, we do have a restriction, and the restriction is going to be that the bottom cannot be 0, so x cannot be 3, because if x is 3, we're going to have dividing by 0. So this is equal to this as long as x is not equal to 3. Okay, so we have some simplifying work to do here. So when we look at it, we could see that 18 over 3 is just the same thing as 6 over 1. And these over here cancel each other out. So we're going to have 6 x minus 2 over 1 times x plus 8. which we could write as 6x minus 12 over x plus 8. So this expression simplifies to this expression. And we have to look at the restrictions. And restrictions, we're going to go, it could be in any step. Often the first one covers all the restrictions. Not always, though. We'll see some examples, not in this lesson, but in some other lessons where they won't. So we know that x plus 8 cannot be 0, and x plus 7 cannot be 0. So x cannot be negative 8, x cannot be negative 7. And so the restrictions here would be, in order from smallest to biggest, x cannot be minus 8 or minus 7. So these two are equivalent as long as x is not one of those two.